The history of physics is filled with victories. In just a few centuries, humanity learned that Earth is not the center of the cosmos, discovered the laws that govern motion, uncovered the existence of atoms, and revealed a universe far stranger than anyone imagined. Black holes moved from speculation to observation. Quantum mechanics explained the behavior of the microscopic world. Space telescopes allowed us to look billions of years into the past. From almost every direction, science appeared to be advancing toward a deeper and more complete understanding of reality. Yet beneath this remarkable success story lies an uncomfortable fact. One of the mysteries in physics has survived them all. That might sound impossible. After all, modern science possesses tools that earlier generations could scarcely dream of. Powerful particle accelerators probe matter at extraordinary scales. Supercomputers perform calculations that would have taken centuries by hand. Observatories scan the universe with astonishing precision. If a mystery has remained unsolved for more than 100 years, surely someone should have found the answer by now. But that assumption hides a deeper misunderstanding about science itself. Many people imagine scientific progress as a straight road leading steadily toward truth. Each discovery answers a question, and each answer brings us closer to the finish line. Reality is rarely so simple. Sometimes a breakthrough solves one problem while creating 3 new ones. Sometimes the closer scientists look, the stranger nature becomes. And occasionally, a single unanswered question refuses to disappear, no matter how much knowledge accumulates around it. Okay? This mystery belongs to that rare category. Generation after generation of physicists has confronted it. Some believe a solution was just around the corner. Others suspected the puzzle pointed toward a flaw in our understanding of reality. Decades passed. New theories emerged. Experiments became more sophisticated. Confidence rose and fell, yet the mystery endured. What makes this fascinating is that the problem is not hidden at the edge of the universe. It is connected to some of the most successful ideas ever created in science. The very theories that transformed physics also exposed a contradiction they could not fully explain. To see how this century-old puzzle first appeared, we have to return to a time when physicists thought they were closer than ever to understanding everything. At the end of the 19th century, many physicists felt a sense of extraordinary confidence. The laws of motion described the behavior of planets and falling objects with stunning accuracy. Electricity and magnetism had been unified into a single framework. The universe seemed to operate like a vast and elegant machine governed by clear mathematical rules. To many researchers, it appeared that physics was approaching completion, but beneath that confidence, a problem was quietly waiting. As scientists began studying light, atoms, and energy more closely, they encountered observations that refused to fit existing theories. The equations that worked so beautifully on large scales started producing strange predictions. Some experiments gave results that simply should not have happened according to the accepted understanding of nature. What initially looked like minor inconsistencies gradually grew into something much more troubling. Then came a series of discoveries that changed everything. Researchers found that energy behaved in ways no one expected. Atoms, once thought to be simple building blocks, revealed an astonishing internal complexity. Light sometimes behaved like a wave, and sometimes like a particle. The deeper scientists looked, the less reality resembled the predictable machine they had imagined. Nature appeared to operate according to rules that challenged common sense itself. This was not merely a technical problem. philosophical shock. For centuries, people assumed that if enough information were available, the future could be predicted perfectly. Cause led to effect. Certainty seemed fundamental. Yet the emerging picture of reality suggested something very different. Probability began replacing certainty. Observation appeared to influence outcomes. Questions that once seemed straightforward became deeply mysterious. Physicists responded with remarkable creativity. New theories emerged to explain the growing mountain of evidence. These theories proved spectacularly successful. They predicted experimental results with incredible precision and unlocked technologies that transformed the modern world. Yet, hidden within those successes was an uncomfortable fact: the mystery had not disappeared. Instead, the new theories illuminated it even more clearly. Every attempt to explain the puzzle revealed another layer beneath it. Every answer generated deeper questions. It was as though scientists had discovered a door at the heart of reality. They could see that something important lay beyond it. But no matter how advanced their tools became, the door remained closed. What made the situation even stranger was that the mystery was not evidence that physics had failed. In fact, it emerged precisely because physics had succeeded. The more accurately scientists described nature, the more obvious the unresolved contradiction became. The puzzle was no longer a gap in the data. It had become a challenge to some of the most powerful ideas ever developed. And that realization led researchers toward a startling possibility. Perhaps the mystery was not simply waiting for another equation or another experiment. Perhaps it was pointing toward something fundamentally missing from our picture of reality itself. More than a century has passed since physicists first encountered this puzzle, and yet it remains one of the most intriguing questions in science. Entire careers have been devoted to solving it. New theories have risen and fallen. Experiments have grown more precise than anyone in the 19th century could have imagined. Still, no explanation has achieved universal acceptance. That persistence is what makes the mystery so remarkable. Normally, science advances by eliminating uncertainty. Competing ideas are tested, evidence accumulates, and eventually one explanation emerges as the clear winner. But some mysteries resist that process. They survive every challenge, not because scientists lack effort or intelligence, but because nature itself may be revealing a deeper layer of complexity than we expected. Today, researchers continue searching for clues. Some believe the answer lies in a theory that unifies the forces of nature into a single framework. Others suspect that entirely new physics waits beyond our current understanding. There are proposals involving hidden dimensions, undiscovered particles, and structures of reality that sound more like science fiction than science. Yet, history has repeatedly shown that reality is often stranger than our imagination. What makes this search especially fascinating is that the mystery sits at the crossroads of some of physics' greatest achievements. It connects ideas that have transformed our understanding of the cosmos while simultaneously exposing their limitations. In a sense, the puzzle acts like a signpost. It points toward territory that science has not yet explored. And that is why physicists remain captivated by it. The mystery is not merely a problem to be solved. It is a reminder that knowledge has boundaries. Every generation inherits the discoveries of those who came before, but every generation also encounters questions that remain unanswered. These questions drive science forward. They inspire new experiments, new theories, and new ways of thinking about reality. And perhaps one day, the mystery will finally yield its secrets. A future scientist may uncover the missing insight that ties everything together. Or perhaps the answer will reveal that our current picture of The universe is only a small part of a much larger story. Until then, the mystery endures. And maybe that is the most profound lesson of all. The universe is not obligated to reveal its secrets quickly. Sometimes the questions that survive the longest become the ones that teach us the most about reality and about the limits of human understanding.